Okay, in this video, we're going to continue with probability distribution for continuous random variable. Okay, recall for discrete random variable, the probability distribution fx, we call it as probability distribution function. Okay, but for continuous, we call fx is as probability density functions. Okay, now let's look at some introduction. Probability distribution for a continuous variable cannot be presented in a tabular form, okay? But as a function called probability density function, or we just put it as PDF, okay? Probability density function. So recall with discrete random variable, okay, the probability distribution function, you can put it in terms of table or in terms of equation or formula, okay? But for continuous variable, we cannot put it into tabular form, okay? We cannot put it into table, but with a function, okay? So in continuous also, it does not matter we include the end point of the interval or not, okay, which is not true if x is discrete random variable. So what is meant by this point is, okay, for example, in discrete, we want to find, for example, probability of x greater equal to 3, okay, for example. So what is greater equal to 3 will be, start from x equal to 3 plus probability of x equal to 4 and so forth, right? If probability of, for example, probability of x greater than 3, if greater than 3 will be, start from probability of x equal to 4 plus probability of x equal to 5 and so forth, okay? So in discrete, these two notation is differ, okay? If x greater equal to 3, so means that 3 is included. If x greater than 3, start from x equal to 4. But in continuous, okay, if include or exclude, it is the same thing, okay? So remember, in continuous, whether include or without inequality sign here, in continuous, it is the same, okay? Later on, I show you the theorem. So that is meant by this point. Okay, the PDF or the probability distribution function is the area under the curve that gives the probabilities associated with the corresponding intervals along the horizontal axis. Okay, what is meant by area under the curve? So the shaded area, the purple one here, means the area under the curve. So this area gives the probability for certain interval. Okay, so if you look at this figure, so all areas are being shaded, right? So means that this is total probability. So total probability should be equal to 1. Okay, however, this area, okay, so area that shaded between A and B, so this is for probability of x greater than A and x less than B. Okay, so in continuous, again, whether include or exclude A, it does not matter. Okay, for continuous random variable, so how to find the probability? We need to apply some basic integration. Okay, so in discrete, what we do in order to find the probability distribution function or the cumulative distribution function. Okay, you total up the probability. Okay, but in continuous, we need to integrate the PDF. Okay, look at this definition. A function with values fx defined over the set of all real numbers is called a probability density function of the continuous random variable x if and only if, okay, if probability of x greater equal to a but less equal to b, so it is given by, so we integrate from a to b fx dx. Okay, so for any real constant a and b with a less or equal to b. Okay, so meaning to say that here is the lower limit, here is the upper limit. Okay, if x is a continuous random variable and a and b are real constants with a less or equal to b, then okay, so look at here. If property of x greater equal to a but less equal to b, so this is also equivalent to x greater equal to a but less than b. Okay, so means that in continuous, this inequality sign does not matter. Okay, because later on we need to integrate from lower limit here to upper limit. Okay, so that's why whether include or exclude does not matter. So this one also will be equivalent to if x greater than a but less equal to b. And lastly, this one also equivalent to if x greater than a but less than b. Okay. Okay, before that, recall from chapter 1, continuous variable. What is continuous variable? So continuous variable are the variables that arises from measuring process. Okay, example, weight. So example of data values for weight, it can be 5 kg, 10.2 kg, 7.3 kg. Okay, so it can take decimal point or it also can take fraction. However, if discrete, only integer or whole number. Okay. Okay, look at this theorem. A function can serve as the probability density of a continuous random variable x. Its values fx values satisfy the following conditions. So the first one, fx must be greater equal to 0. Okay, for the range of x from negative infinity to infinity. Okay, so means that value x must be 0 or positive. It cannot be negative. Okay. And if we integrate fx from negative infinity to infinity from this range, fx dx, so the total must be equal to 1. Okay, so it means that this is basic properties of probabilities. Okay, before I forget, so this point, if x greater equal to a, less equal to b, okay, so this is meant by this point just now, okay. It does not matter we include the endpoint of the interval or not, okay. So means that later on we need to integrate from lower limit here to upper limit here. Okay, now look at this example. Okay, given the following function of x, fx, which is the probability density function for x, so we have 3x squared for x greater than 0 but less than 1. And the probability is 0 for elsewhere. Elsewhere means that if let's say value x equal to 4, then the probability will be equal to 0. Okay, so if x greater than 0 but less than 1, so what is greater than 0 but less than 1? Example, if x equal to 0.5. Okay, so the probability here, fx is the probability density function, will be given by 3x squared. Okay, so I repeat again, 0 for elsewhere. Elsewhere means that, okay, look at this interval. If x greater equal to 0 but less than 1, so example value within this interval is, let's say, x equal to 0.7. Okay, so if x equal to 0.7, the probability is given by 3x squared. However, if let's say x equal to 3, okay, so 3 is not in this interval, right? So if x equal to 3, then the probability equal to 0. Okay, look at A. Show that fx means that this function 3x squared can serve as probability density function for x. Okay, so just now we have two conditions. Okay, so a certain function we can call it or it can serve as probability density function for a continuous random variable if it satisfies these two conditions. Okay. So here look at, let's check the first condition, fx should be greater equal to 0. So since here it gives x greater than 0 but less than 1, so the first condition is satisfied. Okay. Okay, second condition, so if we integrate the PDF, the total should be equal to 1. Okay, let's check the integration part. So I hope you still remember how to integrate simple function. So don't worry, for STA108, it will give you simple function to integrate. Okay, it does not involve integration by parts. It is how you do in your calculus. Okay, just simple function. Okay, now let's integrate. Okay, the interval given is from 0 to 1. So we integrate from 0 to 1, 3x squared dx. So when we integrate 3x squared, we will get 3x power of 3 over 3. Okay, so if we simplify, 3 divided by 3 is 1. Okay, then you substitute. Okay, so x equal to 1. When you substitute x equal to 1, and then minus x equal to 0 here, because you substitute equal to 0, everything will be 0. Okay, so when you simplify this one, total you will get 1. Okay, so if this condition is satisfied, okay, you integrate from lower to upper limit of that function. If you get 1, then we can say that this PDF 3x squared can serve as the probability density function. Okay, so remember, values probability must last from from 0 to 1. Okay, next. Okay, example here, how to calculate probability for a continuous random variable. Okay, let's say question B here. Calculate probability of x greater than 0.1 but less than 0.5. So if in discrete you find the summation for certain values of x, right? But in continuous you need to integrate. Okay, so if you look at here, 0.1 and 0.5 is within this interval, right? Okay, so means that you need to integrate this function based on the limit given here. Okay, so when you integrate, you will get the probability. So that is meant by area under the curve before. Okay, you integrate within the limit given. So here, if we integrate from 0.1 to 0.5, 3x squared dx. So again, 3x squared we will get, if we integrate, we will get 3x power of 3 over 3. Then you substitute the limit given, so lower limit 0.1, upper limit 0.5. Okay, so here 3 over 3 is 1, then we just left with x power of 3. Okay, then substitute value of x. Make sure upper limit first. Okay, so 0.5 power of 3 minus lower limit 0.1 power of 3. Okay, so the probability is 0.124. So again, remember, when you calculate probability, so when you integrate, your answer must be between 0 to 1. Okay, now let's look at this example. Given below is the probability density function fy here for a continuous random variable y. Okay, so here we have two functions. So if y greater than -1 but less than 0, the probability is 0.2. And if y more than 0 and but less than 1, the probability is given by 0.2 plus py. Elsewhere means that other than this value of y, the probability is 0. Okay. Okay, look at question A. Calculate the value of p. Okay, so here how to calculate value of p. So recall the properties of probability. We know that total probability should be equal to 1. Okay, so since this one is a continuous random variable, y is a continuous random variable. So how to get value p? Okay, so first we need to integrate 0.2 from -1 to 0 plus integrate 0.2 plus py from 0 to 1. Okay, then the total should be equal to 1. Okay, so integrate from lower limit to upper limit fy dy, so should be equal to 1. Okay, now we have two functions. Okay, first function is lower limit is -1, so integrate 0.2 from -1 to 0. So here will be 0.2 dy. Okay, so plus 0.2 plus dy. Okay, so total these two should be equal to 1. Okay, now integrate this function. So integrate 0.2y dy, we will get 0.2y. So y equal to 0 and lower is y equal to -1. Okay, and then plus, so integrate 0.2 plus py dy, we will get 0.2y plus py square over 2. Okay, so py square over 2. So y equal to 1. So here y equal to 0. Okay, so total this should be equal to 1. Okay, so substitute value y. So upper limit 0. So 0.2y multiplied by 0, we will get 0. So I put like this. 0.2 multiplied by 0 and then minus lower limit 0.2 multiplied by -1. Okay, plus, okay, this part substitute y equal to 1. So 0.2 multiplied by 1 plus, so y square, 1 square is 1 over 2, 1 over 2. So p over 2, 1 over 2 multiplied by p, we get 1 over 2p. Okay, also equivalent to p over 2. So I put here p over 2 and then minus. So this is when y equal to 1. Okay, minus 0.2 multiplied by 0 plus 0 multiplied by p over 2 will get 0. Okay, so minus 0. So total here equal to 1. So if we calculate here, 0.2 multiplied by 0, 0. 0.2 multiplied by -1, negative 0.2. So negative, negative, positive. So here positive 0.2 plus, so 0.2 multiplied by 1, 0.2 plus p over 2. So here we get 0.2 plus p over 2. Okay, equal to 1. Okay, then 0.2 plus 0.2 is 0.4. 0.4 plus p over 2 equal to 1. So p equivalent to 1 minus 0.4. Okay, so positive to right hand side minus. Okay, then multiply by 2. Okay, so here we will get 1.2. Okay, so value p equal to 1.2. So note that p is a constant. Okay, so the value can be more than 1. Value probability cannot be more than 1 and cannot be 0. Okay, so note here that again p is a constant value. Okay, so that's how we find that constant value. Integrate these two functions and the total, which is the probability, should be equal to 1. Okay, now question B. Find probability of y more than 0 but less than 0.5. Okay, so now look at here. We have two functions. Okay, but now we want to find value which is more than 0 but less than 0.5. So the value of y is within this interval. Okay, y more than 0 but less than 0.5. Okay, so we just integrate this function based on these two limits. Okay. Okay, so take this function only. Okay, integrate from the given limit. So y more than 0 but less than 0.5. So upper limit here is 0.5. So integrate 0.2 plus py dy. Okay, so integrate here, we will get equal to, so integrate, we get here 0.2y plus py square over 2. Py square over 2. For y equal to 0.5 and lower limit y equal to 0. So here substitute y equal to 0.5, we will get 0.5, then minus 0. Okay, so here when substitute y equal to 0, so 0.2 times 0, 0, y power, sorry, 0 power of 0 power of 2, 0. So everything will be equal to 0 here. Okay, then equal to, okay, just now PV is 1.2, right? So substitute y P equal to 1.2. Okay, so when you calculate this one, we will get probability equal to 0.25. Okay, question C, find probability of y more than 1 over 4. Okay, so we know that 1 over 4 also equivalent to 0.25. So if you look at the function given here, okay, locate where is interval 0.12, 0.25 or 1 over 4. So 1 over 4 is located within this interval, right? Okay, so meaning to say that lower limit is 1 over 4, then upper limit will be 1. Okay, because this function is for y more than 0 but less than y. So again, integrate this function, but the limit now is different. Okay, I just copy from here since from the same function. Okay, now y more than 1 over 4 or 0.25. So upper limit now is 1. Okay, because this function until 1, from 0 until 1. So I just change the limit here, lower 0.25. Okay, so now the difference is only the limits. Okay, okay, now substitute y equal to 1. So here y equal to 1. So py, p 1.2, y square. So 1 square over 2. Okay, this is y equal to 1. Okay, minus when y equal to 5. So here 0.25. Here is value y 0.25. Okay, so when you calculate this, the probability is 0.7125. Okay, so remember, if you want to find probability, okay, look at the given limit. Okay, if you have two functions like this, okay, look at the limit given in which function. Okay, later on, I want you to try on your own for example 20. Okay, so in bracket here is the final answer. Later, I will give you the solution. Okay, the working. Okay, look at question A. Find the value of k. Okay, so note here that k is a constant. Okay, so how to find value k? You integrate this function. Okay, k x plus 1 dx, from you integrate from 2 until 4, and then should be equal to 1. Okay, so total probability equal to 1. Then you will get value k. Okay, B, calculate probability of x less than 3.2. Okay, so note here that 3.2 is within this limit, right? Okay, so B, you integrate this function. Once you get value k, substitute value k. So integrate this function with limit from 2 until 3.2. Okay, so in this question, lower limit is 2, upper limit is 3.2. Okay, why upper limit is 3.2? Because now we want to find x less than 3.2. Okay, and last one also the same. We want to find probability of x more than 2.9 but less than 3.2. Okay, so the value also within this interval. So integrate this function with lower limit 2.9, and upper limit is 3.2. Okay, now let's look at on how to find cumulative distribution fx for continuous random variable. Okay, so recall if you use capital F here is to denote the cumulative distribution. Okay, so if lowercase f like this is for probability density function. Okay, for continuous we call it as probability density function. Okay, look at this definition. The cumulative distribution function fx of a continuous random variable x with density function fx is given by, so the cumulative of x equal to probability of x less than value of x, so equal to integrate ft dt from lower limit of negative infinity to x for x from negative infinity to infinity. So if you look at here, for cumulative distribution for continuous random variable, okay, here is the probability density function. So if fx, okay, for example, fx equal to 2x squared, okay, 2x squared. So in order to find the cumulative, so variable x, you replace it by t. Okay, so because cumulative later on you need to integrate until x here in order to get the function. Okay. Okay, look at this theorem. If fx, the density function, and fx here, which is the cumulative distribution, are the values of the probability density and the distribution function of x at x, then probability of x greater less equal to a, greater equal to a but less equal to b can be found by using the cumulative. So this one equal to fb minus fa. Okay, so again this one also, as I explained before, in continuous, so with equality signs or without the inequality sign does not matter. Okay, because later on we need to integrate from lower limit to upper limit. Okay, now let's look at this example. The time in seconds taken for a certain chemical to react and produce light at a given temperature is a continuous random variable y with the probability density function as follows. So fy equal to 3 minus y square over k. So this function is for y greater equal to 3 but less than 5. And elsewhere, the probability is 0. It means that if value y not between this interval, so the probability will be equal to 0. Okay. For example, if y equal to 7, for example, then the probability will be equal to 0. Okay, note here that y, what is our variable here? The continuous variable. So the variable here is the time. Okay. Okay, look at question A. Prove that k equal to 8 over 3. So k here is actually a constant. Okay. So again, how to find value k? We know that total probability equal to 1. We integrate this function from 3 to 5 and then equal to 1. Okay, k, this one you can take out it as 1 over k. Okay, like this because it is a constant. Okay, so if you look at here, the solution. So integrate 3 to 5, 1 over k, 3 minus y square dy equal to 1. Okay, because total probability here. Okay. This one since constant, you can take it out here to ease you for the integration part. Okay, 3 minus y square. So if you expand this one, you can you expand means that 3 minus y square, you can write it as 3 minus y multiplied by 3 minus y. Okay, so when you expand, you will get 9 minus 6y plus y square dy and then equal to 1. So integrate this part, 9 you will get 9y minus 6y. So integrate you will get 6y square over 2 plus y square. Integrate we will get y power of 3 over 3. Okay, then substitute the limit, lower equal to 3, upper equal to 5. Okay, substitute value lower and upper limit into this function. Okay, so when you substitute, you will get k equal to 8 over 3. Okay, so if value k constant, it's okay if more than 1 because not value probability, it is a constant value. Okay, question B here, find Fy. So capital F here is cumulative distribution. Okay, so for continuous, how to find the cumulative distribution? Okay, so let's go back to the theorem just now, or the definition here. So cumulative of continuous random variables, so integrate from lower limit to x. Okay, so if the variable is x, then you integrate up to x. Okay, if fy, then here you replace by y. Okay, so integrate ft dt. Okay, so means that variable x you replace it by t. Okay, because later on we want to get a function. Okay, so here from this example, okay, we know that the equation is 3 minus y square over k. So just now k is 8 over 3. Okay, so later on you replace k equal to 8 over 3 for y greater equal to 3 but less than 5. Okay, so later on y you replace by t. Okay, look at how. Okay, cumulative fy equal to, so integrate from negative infinity to y. Okay, because our variable is y, so if your variable is x, then here replace by x. Ft dt. Okay, so now we want to integrate with the respect to t. Okay, lower limit is 3. Okay, so lower limit is 3 up to y. So upper limit here you put y. Okay, why you put y? Because later on we want a function. Okay. Okay, then 3 over 8 multiplied by 3 minus t square. Okay, how I get 3 over 8? Okay, this is actually value k. Okay, so k equal to 8 over 3. So when you substitute k equal to 8 over 3 here, so if you take it out, you can write it as 3 over 8. Okay. So 3 minus y square, so y replaced by t. So here y replaced by t, okay? So 3 over 8 multiplied by 3 minus t square. So again, similar to step in question A, we can take out constant here, 3 over 8, we take out to do the integration part. So 3 minus t square, so you expand this bracket where you can write it as 3 minus t multiply 3 minus t. Okay, so this one I already skipped one step here. So 3 minus t multiply 3 minus t. So when you expand, you will get 9 minus 6t plus t square. And then integrate with respect to t. Okay, so when we integrate this part with respect to t, so 9 we will get 9t minus 60 will be 60 square over 2 plus t square becomes t power of 3 over 3. Substitute the lower limit t equal to 3 and upper limit t equal to y. Okay, so that's why later on we can get a function because y originally y from the given probability density function, so we replace it by t. At the end of the day, later on we will get y because we will substitute t equal to y. Okay, so here let's look at next step. So t now upper limit is y. So do for upper limit first. This part is for upper limit. So t equal to y. So 9y minus 6y square. This one I already simplified. 6 over 2 equal to 3. Okay, so here we will get 3y square plus y power of 3 over 3. Okay, and then minus. Okay, now substitute the lower limit t equal to 3. So 9 times 3 minus 3 times 3 square. So again, how we get 3 here? 6 over 2 equal to 3. Okay. Plus 3 power of 3 divided by 3. So when you simplify this one, you will get the cumulative function, which is 3 over 8 multiply 9y minus 3y square plus y power of 3 over 3 minus 9. So this part, if you simplify, you get 9. Okay. So if you cannot simplify this equation, then just put your answer like this. Okay. And how to put into how to write the cumulative distribution from 0 to 1 as what we did in discrete random variable. Okay, let's look at next page here. Okay, so how we write? Okay, Fy, the cumulative. Okay, always start with 0 here, 0 to 1. Okay, because this is range of probability. Okay, 0 for y less than 3. Okay, y less than 3, originally our given function, the probability density function is y greater and equal to 3. So if less than 3, the probability will be 0. Okay, so here 0 for y less than 3. Okay, this is the cumulative distribution that we integrate just now. Okay, so this part 3 over 8 multiplied by 9y minus 3y square plus y power of 3 over 3 minus 9. So this is for y greater equal to 3 but less than 5. Okay, so refer to original interval here. Okay, and last one, if 1 for y greater equal to 5. Okay, y greater equal to 5 because here is y less than 5. So that's how we find cumulative distribution for continuous random variable. Okay, for extra understanding and for extra exercise, let's look at another example here. Example 22. Okay, probability density function of a continuous random variable is the fx equal to half x for x greater equal to 0 and less than 2 and 0 elsewhere. Okay, for question A and question B, I think this one no problem. Okay, so A prove that x is a continuous random variable. So how to prove means that we refer to second condition. Okay, so if we integrate this function, if it equal to 1, then we can say that it is a probability density function. But if you integrate, you get more than 1, okay, or you get negative, then this function we cannot say that it can serve a probability density function because the value is beyond the limit of 0 to 1. Okay, question B. Question B also I think no problem for you. So this one similar to previous part. Find probability of x less equal to 1. Okay, so if x less equal to 1, so still within this interval. So you integrate from 0 to 1. Okay, so integrate this function from 0 to 1, then you will get 0.25. So this is very simple integration. Okay, question C. Look at how to find the cumulative distribution function. Okay, fx, so again, integrate from negative infinity to x, ft dt. So our original function before this is half x dx, right? Okay, half x dx. So x replaced by t because later on we will substitute t equal to x in order to get a function. Okay, if you look at here, integrate from 0 to x because lower limit is 0. Okay, half t dt, x replaced by t. Okay, integrate half t, we will get half multiplied by t square over 2. So again, half is actually a constant. So you can take out constant. So integrate t, we will get t square over 2. Okay, then substitute lower limit t equal to 0 and upper limit equal to x. Substitute the upper limit, so x square over 2 minus lower limit, here you will get 0. Okay, so finally we will get function of x squared over 4. Okay, how to write the cumulative distribution? So fx equal to 0 for x less than 0, x squared over 4 for x greater equal to 0 but less than equal to 2, and 1 for x greater than 2. Okay, so why less than 0 here? Because here x greater equal to 0, so here should be less than 0. So x more than 2 because here is less than equal to 2. Okay, now let's look at this example. Distribution function of a continuous random variable y is given by fy equal to 0 for y less than 0, y square for y greater and equal to 0 but less than equal to 1, and 1 for y greater than 1. Okay, note here that here is the cumulative distribution function. Okay, so distribution function is the cumulative distribution function, not the probability density function. Okay, not this one, not the PDF. Okay, so this is this is probability density function. Capital F here is cumulative distribution function. So look at question carefully. Okay, question A, find probability of y greater and equal to 1 over 4 but less than equal to half. Okay, for continuous random variable, if a cumulative distribution function is given to you, so it is very easy to find this probability. So you apply this theorem. Okay, go back to theorem 5.4. So you refer this theorem. Okay, if fx and fx are the values of the probability density and the distribution function of x at x, then probability of x greater and equal to a but less than equal to b is given by fb minus fa. Okay, so note that b is the upper limit, a is the lower limit. Okay, so this is cumulative distribution function. Okay, so again, how to find this probability if we have the cumulative? Just simply fb minus fa. Okay, so note here that here must be the upper limit, here is the lower limit. Okay, so for this question, since we have the cumulative distribution function, so we can apply the theorem 5.4 just now. So now how to find probability of y greater and equal to 1 over 4 and less than equal to half. So this one is given by b is the upper limit, which is half, minus f1 over 4. Okay, so how to substitute this one? You take the function. Okay, so the function is y square, right? So y square, substitute y equal to half and y equal to 1 over 4. So here will be y half square minus 1 over 4 square. So this one, your answer will be 0.1875. Okay, so with cumulative distribution for continuous, it is very easy to find the probability. Okay, B, find probability of y more than half. Okay, so half is between this interval. So how to find this answer? Okay, now you only have more than half. Okay, so based on theorem, fb minus fa. Fb is the upper limit and fa is the lower limit. Okay, so since more than half, so this one will be the lower limit. So here f1 minus f half. Okay, upper minus lower. So substitute 1 equal to into this function y square. So 1 square minus f half, so 1 square is 1, half square is 0.25, so our answer is 0.75. So probability of y more than half is 0.75. Okay, last one, probability of y more than half and less than 1. So again, remember in continuous, for inequality sign here, include or exclude does not matter, okay, because later we need to integrate from lower to upper limit. So for this one will be f1 upper limit minus f half. So if you look at here, notice that question C and D is the same, okay. So this one, the answer will be 0.75 as well. Okay, so that's how you find probability using cumulative distribution function. Continuous random variable. Okay, but for discrete, it's not this way. Discrete is different. Okay, now let's look at how to find expected value of a continuous random variable and its variance. Okay, so here, how to find expected value or mean and variance for continuous is the same as in discrete, but for continuous, a function is given to you, then you need to integrate. Okay, however, in discrete, you just find the summation. Okay, you did not do integration in discrete. Okay, so that is the only difference. In continuous, we do integration. Okay, so if you look at here, expected of x equal to, so you integrate from negative infinity to infinity, x multiplied by fx dx. Okay, so integrate with respect to x. So negative infinity to infinity, again, this is the lower and upper limit given. Okay, for variance, if you look at variance, also still the same as in discrete. So variance of x equal to ex square minus expected of x square. So ex here, expected of x here is actually value mean. Okay, so you integrate. So if expected of x is x multiplied by fx, so if ex square will be x square, so you square x here, multiply by fx dx minus x multiplied by fx. So this is actually the mean value here, okay? And then here you add dx, okay? Integrate with respect to x. Okay, now look at example 24. Okay, the probability density function for x is given by x plus 5 over 50 is for x more than negative 5 but less than 5, and 0 for elsewhere. Okay, find the expected value of x and its variance. So we know that expected of x is integrate from lower to upper limit x multiplied by fx dx. Okay, if you look at here, so expected of x equal to, so integrate from negative 5 to 5. Okay, so based on this interval, x multiplied by fx dx. Okay, second step here, if you look at where I get 1 over 50, so if you look at original function here, so here this constant over 50, so you can take it out and you can write it as 1 over 50, okay? And then x multiplied by fx, x multiplied by fx, so fx is x plus 5 dx, okay? Okay, expand this part, okay, 1 over 50, x multiplied by x, we get x squared, plus x multiplied by 5, we get 5x, okay? Okay, next, okay, so integrate this part, so here 1 over 50, x squared, if we integrate, we get x power of 3 over 3, plus 5x. If we integrate, we get 5x squared over 2. And then later on, you substitute the lower and upper limit. So here, this part, we substitute x equal to 5, the upper limit, minus, here, this part, substitute x equal to negative 5, which is the lower limit. Okay. So when you replace the value and you calculate expected of x, here, value mean, you will get 1.67. So again, this is value mean. So it's okay to get value of more than 1. Okay, now how to find the variance of x? Okay, so we know that variance of x is given by expected of x squared minus expected of x squared. So again, this is value mean. So we already have this value. Okay, now we need to find this value, expected of x squared. So expected of x squared is given by, so integrate from negative 5 to 5 x squared. So don't forget to square here because we want to find x squared here. Multiply by fx dx. Okay, similar in previous part. So 1 over 50 here is actually, we take it out the denominator and we write it as 1 over 50. Okay. So x squared fx, so substitute fx equal to x plus 5. Okay, then this step, we expand this part. Okay, x squared multiplied by x, we get x power of 3 plus x squared multiplied by 5, we get 5x squared. Okay, then integrate this part with respect to x. Okay, next step here. So integrate, we get x power of 3. When we integrate, we get x power of 4 over 4 plus integrate 5x squared, we will get 5x power of 3 over 3. Okay. Okay, this part, substitute upper limit and lower limit. So this is upper limit, substitute x equal to 5 here, minus, so here is lower limit. Okay, substitute x equal to negative 5 here. So when you substitute and calculate, so ex squared, you will get 8.33. So again, it's okay to get more than 1 because this is not value probability. Okay, so this is value of expected of x squared. So how to find the variance? So substitute variance of x equal to expected of x, which is 8.33 just now, minus mean square. So mean just now 1.67 square. So don't forget to square here. Common mistake made by student is to don't forget to square the mean value. So variance of x will be 5.54. So that's how we find mean and variance for continuous random variable. The method or the concept is still the same, but in continuous we need to integrate the function given. Okay, for example 25, later on I want you to redo this example. So this one you have two functions. Okay, so if you have two functions, so again for example question A, how to find this constant value. So when you integrate these two functions, you must equate it equal to 1. Okay, so in order to find value g. So later on you refer this example and redo. Okay. Okay, question B. Okay, find probability of 2y greater than 1 and less than 6. So if you look at here, here is 2y. Okay, so how to find this probability? So take issue, you make or you write it as probability of y more than half, y less than 6 over 2. Okay, so 6 over 2 is equal to 3. So that's why here I put 3. Okay, why we can write in this way? Okay, how I get half and 6 over 2 here. So this is 2y, right? 2 multiplied by y. Okay, so 2 you bring to left and right hand side. Okay, multiply. So to left hand side here will be 1 over 2. So here also multiply to this side will be 6 over 2. So 6 over 2 will be equal to 3. So if you look at here, okay, y more than half, so the interval y square is for y between 0 and 1, right? Okay, now y between half and 3, 6 over 3 equal to 3. So 3 is not within this interval. Okay, so 3 is beyond these two intervals. So how to do this? Okay, for half, more than half, so integrate from half to 1. Why until 1? Because half is within this interval, but the upper limit is 1. So you just integrate from half until 1 using this function. So that's why here we have integrate from 0.5 to 1 y square dy. Okay, so 6 over 2 is 3. Okay, plus, so integrate from 1 until 2, 13 over 6 minus y dy. Okay, y 1 until 2, so here 1, so if upper limit here is 1, so here must be start with 1 again. Okay, so if you look at here, okay, so you look at this interval, so that's why lower limit will be 1. So this function limit is between 1 to 2, right? But here is 3. 6 over 2 is 3. So that's why we integrate from 1 to 2, because this function is for 1 until 2 only. Okay, so that's why here we put 1 until 2 and then integrate 13 over 6 minus y dy. So where we get 13 over 6, because this is value g. Okay, so the function given here is g minus y. So when g is 13 over 6, and then substitute g equal to 13 over 6. Okay, so 13 over 6 minus y dy plus, okay, here is 3, right? Okay, integrate 2 to 3. Okay, because 3 is despite elsewhere. Okay, so the function is 0. Okay, so integrate like this. So 2 until 3, 0 dy. Okay, then integrate as usual. Y square, we get y over 3 over y power of 3 over 3 plus 13 over 6 minus y, we will get 13 over 6y minus y square over 2 plus 0. So integrate this one without any variable of y, you will get 0. Okay. Okay, when you substitute each value of lower and upper limit with respect to its function, so later on, this probability you will get 23 over 24, or also equivalent to 0.9583. Okay, so it's okay for probability. If you want to put your answer in fraction or in decimal, should be no problem. Okay, question C. Calculate the average number of hours that a student will spend on revision. Okay, so average number means that value mean. Okay, expected of y. So how to find expected of y? Integrate from lower to upper limit. Y multiply by fy. Okay, so this one no equal to 1. This one I copy paste, forget to delete. Okay, so just like this. Okay. Okay, look at here. So in this example, we have two functions given, right? Okay, 1, 2. So how to calculate the expected of y? So look at these two functions. Okay, integrate from 0 to 1. So this is the first function. Y multiplied by y squared dy plus y multiplied by fy, which is second function. So y multiplied by 13 over 6 minus y dy. Okay, expand this part. Y times y square, we get y power of 3. And then this part, y times 13 over 6, we get 13 over 6y minus y times y, we get y square. Okay, then integrate with respect to y. So this part, we get y power of 4 over 4. And this part, 13 over 6y, we will get 13 over 6 multiplied by y square over 2. Okay, so y, if we integrate, we will get y square over 2 minus, so y square, if we integrate, we will get y power of 3 over 3. So this one again, you rewrite, and then this part, if you simplify, we can write it as 13y squared, so 6 times 2, 12, minus y power of 3 over 3. Okay, next step, as usual, substitute lower and upper limit to respective function. So when you substitute and calculate this part, expected of y, we will get 7 over 6. Okay, so I hope should be no problem on how to find the expected of y. So you just need to apply the integration concept. And if question asks you to find the variance, so again, how to find the variance? You need to find ey square first. Okay, so find ey square first. So variance equal to ey square minus mean square here. Okay, for example 26 and 27, I want you to try on your own. So value in bracket is the final answer. So later on, I will give answer with solutions, okay, with the working. Okay, note here that, for example, example 27, question E here, determine expected of 3x squared plus 4. So again, this question also similar to discrete random variable. Okay, you follow the rules of expectation. Okay, so example, expected of 3x squared plus 4. Here you can write it as, so this one just we recall back in discrete. So this one you take out the constant 3. So here you can write it as 3 times expected of x squared, and then plus expected of 4. Okay, apply the rules of expectation, still the same as we did in discrete previously. Okay, and also for example 28, I want you to try. Later on, I will give you the answer with complete working. So here also the same, you apply the rules of expectation. Here that answer in bracket here follows sequence of question. Okay, expected of t, this is the answer. Variance of t, this is the answer, and this is answer for last question here. So we already finished all chapters in STA 108. So to sum up, in chapter 5, okay, what we need to know is, okay, how to find the probability distribution for discrete, how to determine whether that given function can be served as probability density function for continuous variable, and also we learn on how to find the cumulative distribution function both for discrete and continuous variable. Okay, so note that for discrete we can represent the distribution, we can represent the probability distribution by using graph, table, or equation or formula. But in continuous, cannot. Okay, we cannot put it in tabular form. And lastly, we learn on how to find expected value, which is value mean and variance for both as well discrete and continuous variable. Okay. Okay, in your books, I already give full solutions and working for past year exam from September 2015 until December 2019. So I hope you make use of this example that I already gave to you. Okay, very complete answer. So I hope this will help you in continuous random variable. Okay, that's all for chapter 5 and we already finished STA 108.